we need to do to check whether the magnet is in motion or not is to check whether there is any induced current in the conductor. But contradiction arises here. If the magnet and conductor are moving together with same speed, an induced current should be produced in the conductor due to movement of magnet with respect to ether. Since the conductor also is in motion with respect to ether, there should be another induced current in it due to motion in a magnetic field. However, if this is true, this induced current should exactly cancel the previous one because experimentally there is no current observed. But for an observer on Earth, an induced current should be produced in the conductor. Thus, the absolute nature of the electric field was questioned. This prompted Einstein to ponder upon which quantities should be considered relative and which should not be considered relative. So, now, ether no longer exists. Hence, light travels with speed, c, not with respect to ether, but with respect to the source of light. Maxwell claimed that light always travels with speed, c, irrespective of the velocity of the source of light and frame of reference. According to Newtonian mechanics, speed of light, as observed by a lady sitting in the train, will be c minus v. Einstein was the first one to notice this contradiction between Maxwell's theory and Newtonian mechanics. One thing that Einstein used to hate was contradiction. In his thought experiment, Einstein concluded that time is relative. Consider a man standing on a platform. Two streaks of light fall on either side of him at a distance x. Time taken by each light ray to reach the man will be x by c. Consider a lady in a train moving at a velocity comparable to the speed of light. The light from ray 1 will reach the lady faster than ray 2. If two observers cannot agree upon simultaneity of two events, then the rate of flow of time cannot be same for them. This proves that time is relative. We can understand time dilation using an example. Consider two friends, Joey and Chandler. Both of them have a time clock with them. Chandler leaves for a mission into space. The ray of light and Joey's light clock travels a distance x in time t. Speed of light is equal to c. That is equal to x by t. Let t be equal to 1 second. The distance traveled by the light ray in Chandler's light clock will be x dash, that is greater than x, due to the speed v of the light clock. Speed of light in both the cases should be equal. Distance traveled by Chandler's light ray is greater than Joey's. Hence, Chandler's 1 second should be slower than Joey's. 1 day for Chandler and the rocket in space can be 50 years here on Earth for Joey. Then, travel at the speed of light.